Lab 3, Bar Magnets by Advaith Nirumukala. The strength of a magnetic field produced by a bar magnet is proportional to some power of the distance. The purpose of this lab is to find the distance dependence and to find the magnetic dipole of the bar magnet. In this experiment, the distance dependence was found to be n equals to negative 2.634, and the magnetic dipole was found to be 11.455 ammeters squared. To find the distance dependence, we will plot the strength of the magnetic field when the magnet is various distances away from the magnetometer. We can then take the natural logarithm of both sides and plot them against each other to find n. For the computational portion, we will be using the general form of the Biot-Savart law, which expresses the vector of a magnetic field given its magnetic dipole and distance and position from the source. In the experiment, a magnetometer was placed to align with Earth's magnetic field such that there was no magnetic field in the x direction. A magnet was placed at varying distances from the magnetometer and the magnetic field was recorded. The data was plotted and graphed with the results displayed to the left, and then it was linearized to directly compare the relationship between the natural log of r and the natural log of the magnetic field. The data was then plotted on a graph, shown later, and the value for n was found to be negative 2.634, which is the slope of the graph. Yes. Plotting the natural log on the y-axis and the natural log of the distance on the x-axis gives a linear trend line with a constant negative slope of negative 2.634. This means that the strength of the magnetic field diminishes proportionally to the 2.634th power of the distance from the magnet. This is close to the theoretical value of negative 3, generally used for the magnetic field caused by a magnetic dipole. For the computational portion of this lab, a function was programmed to calculate the magnetic field using the Biot-Savart law given a magnetic dipole and the distance from a magnet. The value for the magnetic dipole was varied until the computational results matched the experimental results from the lab. The value of the magnetic dipole was found to be 11.455 ammeters squared. To conclude, distance dependence factor is roughly negative 2.634 and the magnetic dipole moment is about 11.46 ammeters squared. Potential sources of error in this lab include a potentially inaccurate magnetometer, inconsistency in the positioning of the magnet, and especially surrounding interference from electronic and metallic objects. If the meter stick had not been oriented to compensate for magnetic north, the results would not have been significantly altered, provided that all calculations were done with vectors as opposed to scalars, since the magnetic field strength of Earth does not change based on the orientation of the compass. If we stuck two identical magnets together, we would likely get a similar distance dependence factor, but a larger magnetic dipole moment due to greater distance between the magnet's north and south poles. Thank you.